Hey, it's Becky, and today we're building something really special, a wood slab chandelier that's way smarter than your average light fixture. Keep watching to learn to build your own. This project is a collab with James Wright, who approached me with his idea to make a gorgeous wood slab into a one-of-a-kind lighting fixture to be suspended from the ceiling. We agreed on the concept with LED strip pointing up to spread the light across the ceiling and a few pendants hanging from the slab to provide downward room lighting and also highlight the grain of the slab. James is an amazing woodworker. Definitely go check out his channel to see how he transformed the raw slab into the foundation for our lighting fixture. James sent me photos of the slab that I could use to sketch out the location of the LEDs, and I got to work on the bill of materials as well. Here's the design, which has a few meters of LED strip and 6 pendants. I created a printable template in Illustrator that James could assemble and attach to the slab to use as a guide for the holes and routing. For the pendants, I wanted to use 2 NeoPixel rings back to back, so they would shine up and down simultaneously. I sketched out a few ideas in my notebook before opening any CAD software. The LEDs I chose are RGBW natural to match the color temperature of the other lights in James's home. I set about designing the pendants for 3D printing using Tinkercad. After a few iterations, I settled on a basic cylinder printed in vase mode, which provides a nice thin, even surface for light to shine through. And they print super fast too. I made a second piece to act as the receptacle for the NeoPixel rings and stiffen the form. Then I glued the 2 pieces together with CA glue. Next, it was time to figure out how James will control the light fixture. Sure, it could just turn on and off with a switched outlet, but Pixels can do so much more. And James mentioned that he's an avid user of Home Assistant, which is an automation platform I've always wanted to try. One approach to controlling NeoPixels remotely is to use WLED. This free software makes it fast and easy to get started remotely controlling pixels, and it runs on most ESP Wi-Fi boards. Plus, it integrates with Home Assistant. I'm sold! So that rounds out this project's bill of materials. And now it's time to take a quick break to thank this video's sponsor, DigiKey. They carry all of the electronics parts and tools you need to build this project, including the NeoPixel strip and rings, Wi-Fi microcontroller, beefy AC adapter, soldering iron, and wire strippers. Projects this big simply would not be possible here on this channel without DigiKey's support. So please consider checking out their vast selection of quality products next time you're making something. And by now, I hope you are aware of my electronics teaching video series on the DigiKey YouTube channel. Great for building your foundational skills before tackling a project like this one. Check out the link in the description for more info on this project and the skills you need to build it. The wiring is straightforward: power, ground, and a single data line to control all the LEDs. But if ever there were a project that needs that big capacitor recommended for NeoPixel projects, this is it. It's got tons of pixels and long runs of wire, as well as an AC to DC power supply that plugs into the wall, which are notoriously noisy. I'm using 1,000 microfarad electrolytic capacitor near the first pixel, wired between power and ground. Soldering all those segments of LED strip together took quite a bit of effort, and the project was quickly growing too big for my small studio. So I hung it up on the wall. Getting WLED set up is one of the most satisfying parts of this project. You flash the firmware directly from the browser, connect to its Wi-Fi hotspot from your device, and within minutes, you've got a web interface controlling your lights. I configured the uplight and pendants as separate segments. So even though the pendants are downstream data-wise from the uplight, WLED can save their addresses and allow you to control them independently. Each pendant gets 2 12-LED NeoPixel rings wired in parallel, and I used 3-strand ribbon wire for a clean look and ran the wire up through the centers of the pendant shades before gluing them in place. I added small clamps to the dangling wires to keep them straight and taut while the glue dries. Okay, so I have to share a mistake I made because it's a good learning opportunity. This project uses a lot of power. 339 RGBW pixels can be hungry, y'all. So of course I used a beefy power supply that's rated for 8 amps and configured WLED's auto brightness control current limiting feature to not use more than that. But I used this connector. This connector is not rated for such high current. In fact, I couldn't find a current rating listed anywhere at all for this part, on any platform. I should have checked, and that should have been a sign to swap it for a connector that's explicitly rated to handle the high current I want to pass through it. Because I didn't do that, and I guess I didn't test the final circuit thoroughly at full brightness either, this adapter started smoking when James turned the light on full blast. I was able to replicate the conditions at home to show you, which you should certainly not do. As I cranked up the brightness, sure enough, eventually the part became hot enough to start burning the plastic housing. If left unattended, this would definitely start a fire. Luckily, it was easy to find some barrel jacks on DigiKey that are rated for the power we need. I made a new brain board for James and was sure to create a lot of conductive surface area for the power and ground connections to move those electrons without heating up too much. And I soldered the jack directly to the board rather than using wires. So that James wouldn't have to solder his pixels during the brain swap, I used splice lever connectors to connect power, ground, and signal to the LEDs. After testing, I confirmed it was still cool to the touch at max brightness and left the circuit on like that for quite some time just to be certain. Then I used Kapton tape to insulate the circuit since it doesn't have another enclosure. James was able to connect up the new brain and perform the necessary troubleshooting to get everything back up and running again. The finished result is this gorgeous wood slab that's now the centerpiece of the room, with lighting that can adapt to any mood or occasion. Check out the video on his channel to learn more about the project in action. This is my first smart home project I've done in a while. I got turned off from the whole thing ever since my Amazon Echo added straw hats to my cart while I was watching Westworld. Even though I love experimenting with technology, maybe especially because I do, I understand that we can't ensure the security of our data connected to the cloud. So that's why I'm excited to use Home Assistant for this project. It's a completely local server, meaning your data stays on the premises, only accessible through your hardline Ethernet connection or your private and password-protected Wi-Fi network. You can buy hardware with Home Assistant pre-installed, or install free software on a Raspberry Pi with a fast SD card, or better yet, an SSD drive. Getting into home automation territory opens up so many possibilities. I plugged in my Home Assistant Green's Ethernet to my router on my studio's super professional networking rack and set up the Home Assistant app. My goal is actually to make my studio projects easy to turn off when the space becomes a guest room. I've got multiple LED installations around here, and for the Home Assistant itself, because it has to run when the room is in guest mode, I used black paper tape to cover up its lights. Some already have Wi-Fi, so I can update their firmware to work with Home Assistant. For instance, this is super easy with WLED, which is fully compatible with Home Assistant. But some projects just plug into power, so I need a few Home Assistant controlled power outlets. I picked up these Sonoff smart outlets because they were inexpensive, and their default software is okay, and it does integrate with Home Assistant after a few steps. But y'all know me, I'm gonna explore the pipeline from customer to electronics tinkerer, which I think is strong among the smart home community. So I'm gonna show you how I flash these Sonoff S31s with Tasmoda firmware, an open source way to gain complete local control. To open it up, pop off the end cap with something thin. Slide out the 2 plastic corner pieces to expose the 3 screws. After removing those screws, the front plastic shell will slide apart from the circuit. On the circuit board at the end, you'll find some labeled pads. Solder wires to 4 of these pads: VCC, ground, TX, and RX. You'll need an FTDI cable, which has a serial communications chip inside. You'll need to install its driver too if it's your computer's first time using it. Use the Tasmoda web tool to flash the firmware. Hold down the button while plugging in the USB cable, and don't let go for 5 seconds after. If the web tool doesn't recognize it right away, unplug it and try again. Once everything's flashed and configured, putting the outlets back together is just the reverse process of taking them apart. I plugged my projects into the modified outlets and added them and my WLED projects all to a group in Home Assistant, so I can turn off all ambient lights with one tap. For me, this project has been a fun excuse to finally dive into Home Assistant, which I'm definitely going to use for more projects in the future. If you found this tutorial helpful, don't forget to like and subscribe for more DIY projects, and catch up on my past projects by signing up for my email newsletter. See you next time! This video was made with support from my sponsors and from donations from viewers like you through Patreon and YouTube memberships.